In this video, now that we have a sense of familiarity with the AsyncAwait syntax, it's time to put it into practice. We're going to do a little work together, then there'll be a challenge, then a little more work, and then a second challenge, trying to give us some real hands-on experience. So let's talk about where we're going to start. We're going to close all of our open files, collapse the playground directory, and move back into Task Manager. Together, we're going to convert promisechaining.js to use AsyncAwait. Then you'll do a challenge where you'll convert promisechaining to. Then we're actually going to move into index.js and use AsyncAwait inside of the Task Manager API route handlers, which I'm really excited to get to because it's going to allow us to clean up the code pretty significantly. So to get things started, what are we going to do? Well, right here, we'll go ahead and kick things off by creating a new function. That's going to be the async function. Remember, to use AsyncAwait, we have to start with an async function. So right here, I can call this something like update age and count, describing what it's doing. I will then set it up as an async function, and right here, I'll use an arrow function. Now, using async isn't limited to arrow functions. I could use it with standard functions or with the ES6 method definition syntax if I was defining a method on an object. Right here, though, let's go ahead and actually get done what we need to get done. Now, for this one, we do need to accept some input. That is going to be the ID of the user we're updating, and we're also going to accept the age they want to change to. Down below, we'll use those two pieces of input to go through the process. Now we're working with two methods that return promises, find by ID and update, and count documents, and we'll be using await with both. The first thing we're going to do is call find by ID and update. So right here, I'll create const user, and I'll get its value from awaiting the following promise, user.find by ID and update, and we'll pass that ID in right here. That is the parameter from up above. So we're just going to pass it through to the function. Now we also want to provide the updates we're trying to apply. So we'll have our object right here where we set age equal to the new age, like 0. In this case, we have a variable called age from up above, which we're going to use. And since we're setting the property to a value that comes from a variable of the same name, we can just use that shorthand we explored earlier in the class. So right here, we have our first call all done. And now we can move on to the second one, where we get the count. I'm going to await the following, user.countDocuments. And here we are looking for documents where age equals the value passed in for age. So once again, taking advantage of that ES6 syntax like we did up above. Now we have access to both the user and the count, and we can choose to return whatever we want to. I could return an object adding both of these on as properties if I wanted to access both of them, or I could return an individual one, such as returning count right here. So at this point, we can now go ahead and use our function, and that's exactly what I'm going to do down below. Update, age, and count. I will provide those two arguments. I'll copy the ID from up above, pasting that in, and then I'll pick a new age. I'll bring that person from 1 to 2. So right here, we now have the exact same functionality set up using AsyncAwait. We could also go ahead and add on then and catch to handle any potential errors or to do something with the result. Right here, I'm going to get access to the count. Now, this could be called anything I want, but I'm calling it count because I know it's going to be the count. That's what gets returned from the async function. Right here, console.log, printing count. Then I could set up catch down below, doing the same thing, getting our error, and dumping it to the console. Console.log e. Perfect. So now we have everything in place and we can go ahead and test our work. What I'm going to do is comment out the chaining example up above, though I'll leave it in place, and we are going to run the file testing that our user gets updated. Over inside of Robo3T, I have my list of users right here in that first tab, and if I refresh things, I have a couple of users with the age of 1. Let's go ahead and run the script and see what we get. cd /task manager. And from here, we're going to run the file. That is node playground /promise chaining.js. When I run the script, we should see the output showing up. Right here, I get my count 1, which is fantastic. Now that we have this in place, we can go ahead and make sure that things did indeed update in the database. I'm going to move over to Robo3T, refresh, and right here, the age is now 2. And the reason I'm seeing 1 is because only one user has that age. With this in place, we have now used async and await to do something with Mongoose, and this is the first of 4 things I wanted to do in the video. The second, as mentioned, is a challenge where you're going to use AsyncAwait with the other example, where we deleted a task by its ID and then figured out how many tasks we still needed to complete. Let's go ahead and talk about what I'd like you to do. Right here, there are a few steps for getting this one done. So the goal is to use async and await. You're going to create a new function, an async function called delete task and count. That's going to perform the 2 operations we have up above. You're going to accept the ID of the task to remove as the only parameter for the function, and in the function body, you're going to use await to delete the task and to count up the incomplete tasks. Now your new async function should return the count to the caller, and that brings us to the next step, which is to call the function, attaching then and catch like we did in the other example. Last up, test your work. Find a task to delete and make sure it actually gets removed correctly. Take some time to knock that out, test your work, and check the count for correctness. When you're done, come back and click play. How'd that go? Let's go ahead and kick things off together. What I'm going to do up above is comment out the previous chaining example and focus on the new one by defining our function right here. So const delete task and count. Now we want to set this up as an async function so I can actually use await inside of it. I could use any type of function I wanted to. Here I'll just use an arrow function. Inside of here, we want to make sure that we are accepting the ID of the task to delete, and the next thing to do is to perform those 2 operations we had up above. First is delete the task, second is count up the incomplete tasks. Right here, const task equals, we'll use await with the following promise. It's the one that comes back from calling task dot find by ID and delete. And we're going to provide the ID, which we have as the first parameter. So that is the first async operation. Now, after that's done, we're going to perform the second, which is to get the count, the incomplete task count right here. Once again, using await with task dot count documents, because count documents returns a promise. If these methods didn't return a promise, we wouldn't be able to use them with await. Now, what do we want to provide to count documents? Just our filtering criteria. I only want to count documents where completed is equal to false. I don't want to count those completed tasks. Next up on the list, we want to make sure to return something meaningful, and right here, I'll just return the count. Now it's time to actually put this to use. Down below, I'm going to do just that. Now I do need the ID of a task to remove, so over in Robo3T, I'll head back over to the Tasks tab. If I refresh things, I have just 2. I'm going to go ahead and delete the second one. I'll edit the document just to grab its ID, and I'll bring that ID over to Visual Studio Code. From here, we can now call the function delete task and count. I'm going to provide that ID as the first and only argument. Then I can set up my then call where I get access to that count. And I can also console.log it. And finally, we'll go ahead and set up a catch call where we get access to the error. And right here, we'll log that as well. Perfect. With this in place, we can remove the challenge comments and actually test things out to make sure that the new code works exactly as the old example did. Now you'll notice, while we do indeed get a value back from find by ID and delete, we're not actually using it. If we wanted to, I could have just the following. This is also perfectly valid and would function the same way. The only advantage of actually storing the result in a variable is that I could use it if I needed to. In this case, though, I happen to not need the task I got deleted. I'm going to save the program and run things from the terminal. Right here, that would be node playground/promise chaining. That's number2.js. So I'm going to take a quick moment to run this. I can see my count of 1 printing, and if I refresh things over in Robo3T, I can see my 1 task was deleted, and the reason I'm getting 1 is because I have just 1 left. So there we go. We've used AsyncAwait together, and you've now used it on your own. Now this example does indeed use those Mongoose methods, but it's not exactly part of our task manager application. So what we're going to do is shut things down from the terminal, clear the terminal output, and we're going to close down both of these files. We used them to get comfortable with the syntax, but what I really want to do is explore how this is going to help us build out the task manager REST API and create code that's easy to write and maintain. So in index.js, we already have a bunch of different routes. These are our various predefined operations, and all of them are doing something asynchronous. And you can see that in every single one of them, we have calls to then and catch to do something with the promise, whether it's fulfilled or rejected. What we can actually do is make all of our route handlers, these functions, async, and then we can use AsyncAwait inside of them to create code that looks a bit more synchronous. I wanted to cover that in this lesson, but to keep these lessons at a reasonable length, I'm going to push that off to the next one. So if you do have time, go ahead and jump right in. Otherwise, watch that lesson the next time you get a chance.